In this video, we are going to review the second half of Chapter 7 for Algebra 2, getting ready for our test. The first 6 questions here say to evaluate the log, but do not use a calculator and to show your work. There will be a portion of your test where you will not be allowed to have a calculator. Our first one is actually one of our properties of logs. It says the log base b of b to a power. If we have the log of some base, and we're using that same base and raising it to a power, we just end up with the power. Our reasoning, if we think of doing this, rewriting it exponentially, we're saying b to some power has to give me b to the 5th power. Well, then x would have to be 5. All right, our second one, again, thinking of it exponentially, 2 to some power has to get me 32. This is one where I could think of a common base of 2. So 2 to the x would be 2 to the 5th. 32 is 2 to the 5th. So then again, x has to be a 5. For question 3, 6 to some power has to get me 216. Our common base for this one would be 6. We have 6 to the x equaling 6 to the 3rd. So my unknown power has to be a 3. Our next few are a little trickier because they involve some fractions. Question 4, our base is 1/3. We have to raise it to some power to get us to 1/27th. Our common base would be 3, or we could use a common base of 1/3 if we want to keep it in their fraction form. All right, so our power would have to be 3. 1/27th is 1/3 cubed. All right, question 5. 36 to some power gets us 1/6. If we think of a common base of 6, 36 is 6 squared. We raise that to an x power. We end up with 6 to the 2x. Our 1/6 is the same as 6 to a -1. That's what caused it to give us the reciprocal. Flip it over. So that means that 2x has to equal -1. So x would have to be -1/2. All right, question 6. We have 1/5 to some power getting us 25. Again, thinking of a common base, we could use a base of 5. So 5 to the -1, and then to an x power would be 5 to a -x. On this side, 5 squared is the same as 25. So -x equals 2. X would have to be -2. So that's the type of question that you would be asked with the no calculator portion of the test, and you would have to show that kind of work. Our next section is solving exponential and log equations. It does say, if necessary, round to 4 decimal places. For our first one, we have an exponential equation. We are going to subtract 2 to the other side. That gives me -4 to the x being -64. I then divide out a -1, so I have 4 to the x equaling +64. And then using the same idea we had in the first 6 questions, finding a common base. 64 is the same as 4 cubed, so 4 to the x equals 4 to the 3rd. X would have to be 3. Question 8 is another exponential one. This time we have a natural base of e. My first step is to divide everything by 4. So e to the 2x equals 21/4. And then to solve for x, I can't use a common base like I did in question 7. So what I'm going to do is take the log of both sides. And since I have an e as my base, I'm going to use the natural log because that involves base e. So I have the natural log of e to the 2x equaling the natural log of 21/4. This is a situation where we are taking log base e of e to some power. When these two bases match, our answer is just our power. So on the left side, we just end up with 2x. The natural log of 21/4 will be a decimal. So we'll take our calculators to do the natural log of 21/4. Once we have that decimal, we can divide out the 2, and we should end up with 0.8291. Question 9. Log base 3 of x plus 2 equals 5. It is already a log equation. We solve log equations by converting them to their exponential form. So 3 to the 5th power has to get us to x plus 2. Remember that the answer to a log statement is always a power. 3 to the 5th is 243. We then would have to subtract 2 from both sides, and we'd have 241 for our x. Question 10, it is a log equation. There's a natural log of x in there, but there's some extra pieces that we need to get rid of before we convert it to exponential form. So I'm going to subtract a 5 over first. That gets me negative 6 times the natural log of x equals 2. Then I'm going to divide out the negative 6. So I have the natural log of x being negative 1/3, and now I can write it exponentially. My base when I see natural log is an e, so e to the negative 1/3 will have to give me my x value. And then we'd use our calculator. E to the negative 1/3 is 0.7165. All right, question 11. Notice that on this one we have 2 logs. We have to condense that down to 1 before we can do anything else. So this becomes the log of 4 times x equaling 2. When you condense the sum of 2 logs, it becomes the log of the product, 4 times x. Our base in this case is a 10. This is called common log since there's no other base written. We are in base 10. So 10 to the 2nd power has to give us 4x. 10 squared is 100. When we divide, x would be 25. All right, so that's the review of solving exponential and log equations. For our next ones, we are just writing each equation in logarithmic form. So we're not solving anything, we are just putting it in its alternate form. For question 12, we have 5 to the 4th power. So our base is 5, we're raising it to a 4th power, and we end up with 625. When I write this in log form, my base has to be the number that's being raised to the power, so my base is 5. My answer in a log problem is always the power, which in this case is the 4. So I'm taking the log of 625 in base 5. Question 13. Our base is 4. We're taking the log of 0.015625, and we end up with a power of negative 3. Question 14 is a little different because they're all variables, but we can still look at this as a base of a being raised to a b power, getting us c divided by d. So our base is a, our power is b, so we are taking the log of the quotient c divided by d. Log base a of c over d equals b. All right, our next section, we are condensing. If you see a subtraction sign, when we condense it, it goes back to division. So this becomes the log of 3x divided by 9x. And then if we can do any reducing, we should. So in this case, our x's would drop out, and our 3/9 we could reduce to 1/3. So we're looking at the common log of 1/3. Question 16. We have some powers here that have to go back. Those front numbers go back as our powers. So we have the log of 3 squared minus the log of 4. Again, we are in base 10. 3 squared would be 9. And subtracting a log of 4 means we were dividing by 4. So the log of 9/4. For question 17, notice the 1/2 is in front of parentheses. That means it applies to all of the stuff inside. So I'm going to condense the pieces inside first. We have log base 3 of 49 plus log base 3 of x. Addition is going to condense down to multiplication. So this is log base 3 of 49x Now we can put the 1/2 back as a power. A 1/2 power is the same thing as a square root. So we can write this as log base 3 of the square root of 49x. And we could take the square root of 49. We could clean that up a little bit. Log base 3 of 7 times the square root of x would be your simplified answer. The next piece has us expanding logs, so we're doing the reverse. In this first one, we're actually going to use all three of our log properties. We have a product, 3 times a. We have a quotient, the 3a is being divided by the b squared, and we have a power where the b is being squared. So pulling this apart, we'd have log base 4 of 3. A product here gets split up as addition, so log base 4 of a would get added in. And then our quotient gets expanded into subtraction. So we are subtracting log of b squared. Then we do have this power here that we should move to the front. So we have log base 4 of 3 plus log base 4 of a minus 2 log base 4 of b. All right, question 19. We have a product, the 8 and the square root of y are being multiplied together, so we're going to pull those apart as addition. Log base 2 of 8, we can simplify that because that's saying 2 to some power gets us 8. And that would clean up to be just a 3. For the second piece, log base 2 of the square root of y, that square root can be thought of as a 1/2 power, and that gets moved out front. So we'd have 1/2 log base 2 of y. Question 20 deals with the change of base. The change of base formula says if you are taking the log of some base of, say, n, we can redo that. We can take the log of n divided by the log of our base. And we just have to convert it to some other common base. So in this case, we are using base 10. We could also use base e because we do have a key on our calculator that will do that. So we could do the natural log of n divided by the natural log of our base. Those will get us the same answer either way. So if I want to do log base 3 of 35, I'm going to take the log of 35 and divide it by the log of 3. In this case, I am choosing base 10. Again, we could have done the natural log of 35 divided by the natural log of 3. We'd get the same answer. The one thing to watch for when you're using your log keys on your calculator, a parenthesis is usually inserted when you type the log key. Make sure you close that off before you divide by the second part of that. In this case, the log of 35 divided by the log of 3 comes out to be 3.2362. It did say to round to 4 decimals. And the last part that we need to review for our test is the graphing of logs. It says to graph each function showing the parent function and then the translation. We are asking you to graph the asymptotes as well as the original and the transformed graph. Use at least 3 points for your table. So this first one, we have y equals log base 4 of x. There are no transformations happening on this, so we're just going to graph that parent function. To graph logs, our first step is to rewrite it in exponential form. So again, we're doing that circle idea. So 4 to some power y gets us x. And then our trick is to pick our y values. I'm going to pick from -2 up to +2. It says we have to show at least 3 points. I'm going to have 5 points in the table. Then if some of them are either too big or too small, we still would have enough. So plugging those values in for our y. We have 4 to the second power would be 16. 4 to the first power would be 4. anything to the 0 power is 1. 4 to the negative 1 is 1/4. And 4 to the negative 2 is 1/16. Now again, 16 and 1/16 are going to be kind of hard to graph with the scale that I have here, but I still have 3 other points that will work. My second point here, 1/4, negative 1. That means if I move to the right 1/4, I'm going to be down 1. I also have the point 1, 0 and the point 4, 1. So a log graph, a very typical log graph that hasn't been transformed, is going to come up following along the y-axis and then curve off to the right. My asymptote in this case is right here on the y-axis. It has an equation, x equals 0. My domain is everything to the right of that. So my x's have to be bigger than 0, to the right of 0. My range for y can be all real numbers. All right, and our last one. This one does have a transformation. Right here, we are moving right 1. So I'm going to hold off on that. I'm just going to think of it as y equals log base 3 of x. That's my parent function. I'm going to write it exponentially. So I have 3 to the y equaling x. I'm going to pick my y values again. And I'm going to dump those in for my y here. So 3 to the second power is 9. 3 to the first power is 3. 3 to the 0 is 1. 3 to the negative 1 is 1/3. And 3 to the negative 2 is 1/9. So again, plotting those points. Over 1/9 down 2. Over 1/3 down 1. 1, 0. 3, 1. And 9, 2. Now I have to move those values to the right 1 for my transformation. So my graph is going to come up along that line. And the asymptote here that I'm being asked to draw in is going to have the equation x equals 1. All of my x values are to the right of 1. So x has to be greater than 1, and range for log graphs is always all reals. All right, so your homework is to work on that supplemental practice worksheet. Make sure you ask if you have any questions.